Logarithms, they're powers. And a power is always to some base. So if we look at this example, the logarithm of 3 means the logarithm to the base 10 of 3. And if you get your calculator out, you'll see a log button on there, LOG. It doesn't say the 10, so it's assumed that the base is 10. That log button always has base 10. So if I work out what the log of 3 is, I get 0.47712. The key thing to realize is that 0.47712 then is the power of 10, which gives 3. So if on your calculator you work out what 10 to the power 0.47712 is, you should get near enough 3. You won't get it exactly because we rounded this to 4 significant figures. But that's the idea. 10 to the power 0.47712. The logarithms, using logarithms, turns a number into a power, which can be useful. And the power is to any base we want. So we use 10 because it's a convenient number. So the number on your calculator, the button on your calculator, if you press log of a number, it gives you the power of 10 that gives that number. Okay? Let's look at an example. If I want to work out what 3 times 4 is, well, I know what 3 times 4 is. It's 12. Okay? But if I work out what the log of 3 is, that's 0.47712. So 10 to the power 0.47712 is 3, effectively. What's power of 10 gives 4? What would I have to work out? What would I have to do on the calculator to find this power, this missing power? Log 4. So what's log 4? Give it to me to 4 significant figures. Okay. 1. So, in other words, 10 to the power 0.6021 is 4. Okay? If I want to multiply them together, though, using the laws of indices that we've just been looking at, what do I do with the powers? Add them together, yeah. The base is the same, so add the powers. What's 0.47712 plus 0.6021? Oh, 0.79. Okay. So in theory, that should be 12. So what is 10 to the power 1.07922? And hopefully you'll get roughly 12. So what about 3 cubed? We know 3 cubed is 27. We know that 3 is 10 to the power 0.47712. So how do I work out what 10 to the power 0.47712 to the power 3 is? Which law of indices helps us here? When I've got one power raised to another power, I times them. So this will be the same as 10 to the power 3 times 0.47712. What's that? Gives us 10 to the power 1.431. If we work out what 10 to the power 1.431 is, we should get near enough 27. Okay? To a close approximation. And obviously, the more decimal places we give to our logarithm, the nearer the answer will be. So what this is demonstrating is that you can use the laws of indices. To multiply numbers together, I add the logarithms. And to raise a number to a power, I multiply the logarithm by the power. Okay? And that summarizes the laws of logarithms. So what I need you to do is just make a note of these 3 laws of logarithms, which summarizes them. If I want to multiply 2 numbers together, I add the logarithms. If I want to, similarly, we could have shown that if I want to divide 2 numbers, I subtract the logarithms. And finally, if I want one number raised to a power, I multiply the logarithm by the power. the three laws of logarithms that we'll use a lot.